Bismillahirrahmanirrahim. Assalamu alaikum everyone. Welcome back. So this question is addressing your problems on loops. In particular, the question regarding the safe prime numbers. So mind you, before you attempt this question, you need to cover that video which covers how do you determine in MATLAB whether a given number is a prime number or not. So if you haven't watched that video, please go through that video first and then attempt this question. So this question is, a safe prime is a prime number that can be written in the form 2p plus 1 where p is also a prime number. For example, 47 is a safe prime since 23 is also a prime number, since it follows this 2 times 23 plus 1, which makes 47. So what you're required to do is you're required to write a computer program, MATLAB in your case, that finds and displays all the safe primes between 1 and 1000. So you know that you have to start from 1, you have to end at 1000. So here you need to check all the numbers between 1 and 1000. So since you know you have to start from 1 and end at 1000, you know you are going to go for loop, right? So first thing first, for the first outer loop, you're going to go for all the way from 1 all the way to 1000, constant spacing 1, because you will be checking not only 1, not only 1000, you'll be checking 2, 3, 4 all the way to 1000. Also, the question has restricted you that you're not allowed to use the MATLAB's built-in function isPrime. Now, what is an isPrime function that I did not cover in the last video? If you notice that if I write down any number, for example 8, and I check it on isPrime function, notice that it gives the answer of 0. 0, logical 0 means false, meaning 8 is not a prime number. Similarly, if I apply isPrime function on any prime number, for example 7, it will give the logical answer as 1. That means it's true that 7 is a prime number. Now, the reason that you're not allowed to use this function, this is a built-in function, right? And being a beginner level programmer, you need to know, right, that what did the MATLAB designers designed this function? How did they design it? As in, what sort of coding is inside this isPrime function? So isPrime function definitely has a certain code inside it. So what code is that? You need to learn, being a basic level programmer. So therefore, they're not allowing you to use isPrime function. Otherwise, the whole concept of while loop or the for loop will fail here. So it's better not to use all these built-in functions. Rather, use your own loops. Use your own code in order to determine whether a number is a prime number or not. So now in this question, please note that all the safe prime numbers will be essentially prime numbers. So the very first thing is that we need to determine prime numbers first. Now in the previous video that I covered, it was asking you, or you were giving as an input directly the value, the number itself, which you wanted to check whether it's a prime number or not. Now here we know that we need to check all the numbers from 1 to 1000. So very first thing that you may need to do is open up your script file, write down the loop from 1 all the way to 1000. Now these are all the numbers all the way from 1 to 1000 that you need to check. So there in the previous video you were giving the number 7, 8, 9, whatever. Here you are going to check for all the numbers. So 1 is going to be checked, 2 is going to be checked, 3 is going to be checked all the way to 1000. Now, if you remember in the previous video, or if you remember by prior knowledge, that 1 is not a prime number. So you do not want k, if you do not want 1 to go through any checks, number 1. Number 2, I would like to let you know that in this very question, we are going to split our question. In the first part, we are going to first create a vector containing all the prime numbers between 1 and 1000. Fine. So between 1 and 1000, we are going to create a vector, and that vector will have all the elements that are prime numbers. Then after we have that vector, then we are going to use that vector in order to determine which among those prime numbers are safe prime numbers. So you're getting my point. So there will be essentially 2 loops going on, or 2 set of programs going on. So if I isolate, I'm going to tell you this is part 1 of the program, where I'm going to create vector of prime numbers from 1 till 1000. Obviously, not all numbers between 1 and 1000 are prime numbers. So what are those prime numbers? We are going to save them in an entirely different vector. So very first thing, you need not to check anything. You need not to check for the first pass. So what I'm going to do next is I'm going to write down if, and I'm going to write down that if the value of a in the first pass obviously is 1, do not check it. Continue skipping it. Continue skip this pass. So continue means that this pass needs to be skipped entirely. So what I've written down is if k's value is 1, which will be in the first pass, the k's value in the first pass will be 1, skip it. Continue means skip the entire pass. So everything after continue will be skipped because I know that a1 is not a prime number. So I need not to check it. Secondly, if you recall, I mentioned that key value, if it's 2, it's also it's known to you that it's a prime number. So you need not to check this number as well. Don't check it. Why? Because if you recall in the previous video in the lecture, I explicitly said that you are going to check all the numbers by dividing them by 2, right? So 2 will be the initial divisor. So when 2 is that number which you are checking and you are going to divide by 2, definitely it will divide by the number 2. And the remainder is going to come out equal to 0, and that is your set, that is your condition that is setting the prime numbers and the not a prime numbers apart. So what you can do here is you can, again, no need to check 2 because you know that it is a prime number. Just save it in the vector p, create a vector p and save the value of 2 into it. Now mind you, because I want to create a vector of prime numbers, so I would want certain kind of array addressing to be done here so that vectors positions and vectors values are retained in their respective positions. So what I'm doing here is that in the second pass, when k's value is 2, I'm going to assign a variable I and I'm going to assign a value of 1 to it. And in that very pass, I'm going to say that assign the first value of p as k, which is what essentially 2. So in the second pass, first pass nothing happened. In the second pass, when the value of k is 2, i's value was assigned as 1, and p, which is a very new variable that you are talking about, the first value of p is assigned as k, which is what? 2 in the second pass. Now let's talk about the other passes. It's giving an error. Why? Because I need to end it. Fine. Chalo. Now for all the passes, so else will work for k key value 3 all the way to k key value 1000. So for all the cases, you need to check all the numbers. So now this essentially, for example, if you're going to begin, let's talk in relation with k key value as 3, because we'll begin checking now from k's value 3. So first thing first, you need to add your divisor. Now again, if you're unable to understand what is happening here, please go back and check that video out. So n's value, the first divisor that we are going to assign will be 2. So we are going to check it by first dividing by 2, then 3, then 4, all the other numbers. Anyway, then I'm going to create my remainder, and my remainder is going to be, let's say, k, comma, n. Now since I'm talking about k, in the third pass, the value of k is 3 and the value of n is 2. So the remainder here will come out equal to 1. Now whenever my remainder is not equal to 0, that means I need to check it further. Now in case of 3, I need not to check it because the next number will be 3. So I don't need to check it. But for example, if the number is 7 here, if the number of k is 7 here, so I need to check it with 3, 4, 5 all the way to 6. Fine. So in order to do that, what I'm going to do is I'm going to enter the while loop. Now when I'm going to enter the while loop, what condition I'm going to give is when the remainder is not equal to 0. If it is 0, it established that it is not a prime number. But if it is not equal to 0, check it with the other divisors. So how will I check it with the other divisor? The first divisor was n key value is 2. Now the second divisor will be n key value n plus 1. Now in our case, in the third pass, n's value is 2, right? And the value of k is also now when you have entered the loop, the n's new value will become 3. And here in the third pass, the value of k is 3. And like I said, we will not divide by the number itself, because when 3 will be divided by 3, obviously the remainder is going to be equal to 0. So we need not to go that far. So what we are going to do here is we are going to break it. We are going to say that if this happens, break it and do not find out any further remainders. So in this case, when n key value is 3 and k key value is 3, see 3 is equal to 3, so break. So the loop, this while loop will be broken. It won't be carried out further. If, for example, for 5, if the value of k is 5, in that case the remainder will be 1. Now, when the remainder is 1, that means it's not equal to 0. N plus n1 will be 3, k key value will be 5. Now see, sorry, k key value will be 5. Now is 5 equals to 3? No, it's not true. So this will not work, this will be skipped. Now what you need to do is find the new remainder. And the new remainder is going to be what? K with respect to n. Are you getting my point? Fine. Now check it for all the new devices up until it reaches up there. When it reaches up there, break the command. Now, after it runs this while loop, obviously there is going to be the value of r either equal to 0 or not equal to 0. If it is equal to 0, it is not a prime number. That's not our concern. Our concern if it's a prime number. And a prime number will be when it has run through all this program, all this looping, and still r is coming out not to be equal to 0. What we are going to do is we are going to write down if r is not equal to 0. In that case, that is a prime number, right? That very k is a prime number. So what you need to do is you need to give the counter for the index in the case value when the case value was 2, in the second pass was 1. So the first value of p was assigned as 2. Now in our case, the I will be increased when there are prime numbers. Obviously, whenever the prime number is introduced, increase the counter of I and increase it by 1, and then introduce the ith value of p as k. So in the third pass, for example, when the k's value is 3, right? And for the k's value 3, r is not equal to 0. In that case, i's value will be 1 plus 1, which will be 2. So assign the second value of p as 3. So far p by the third pass will be developed as first value 2 already assigned, second value 3 already assigned. Then it will run the third pass, nothing will happen because 4 is not a prime number. Then for 5, again the third value will be assigned as 5, so on and so forth. So this should work. And what I'm going to do is, while if this is this for, if this is if this and fine. Now what I'm going to do is, I hope I have put a suppressor on each and every, at the end of each command here. I don't want unnecessary displays. It does look like it is there. Now let's display p. P is a vector of prime numbers containing all the prime numbers between 1 and 1000. Let's see if it's working. Here we go. So see, 2, 3, 5, 7, 11, 13. See, if you notice, all these numbers are prime numbers. So far we are done with determining prime numbers between 1 and 1000, which are prime numbers. Let's stop at this point. Then let's have this video saved as part 1. I'll continue with part 2 in the next